Today, we are building a team task manager web application using Python, Flask, SQLite 3, and SQLAlchemy. If you are a beginner, here is a quick breakdown. Flask is a Python framework used to build a web application. SQLite 3 is a database. We'll use it to store data. And SQLAlchemy helps us interact with database. Hey guys, my name is Vivek. Welcome to my channel. In this video, I'll show you how to build a complete web application using Flask SQLite 3 by creating a team task manager from scratch. I'll explain all the important concepts, logics, and everything you need to know to build a project like this one on your own. If you are new to my channel, make sure to hit that like button and subscribe for more Python project videos. Here's a quick demo of the app. You can register as either an admin or a member. So you have two roles, admin and member. Admin can view all tasks created by members. They can also create, edit, delete, and share tasks with members. A member can also create, edit, delete, and share their own tasks with other members or with the admin. They can also view all tasks that are shared with them. Now let's set up our project structure. I'm going to create the project folders along with the Python files and HTML templates. So let me quickly complete this activity. Next, I'll activate a virtual environment. To save time, I am going to use the virtual environment I created earlier for the inventory app. But if you want to create a new one, feel free to do that. Just install it using this command, python-m venv and activate it using below commands. First command is for Windows and second is for Mac and Linux users. Let's get started. When building a Flask app, it is best to start with models.py and app.py first. This helps you define the logic, routes, and data structure before jumping into the HTML templates. Once you know what data you are working with and how your routes behave, designing the front end becomes much easier. Think of it like building the foundation of a house before decorating the rooms. So backend first and then front-end. Let's now look at the heart of our application, the models.py file. This is where we define the structure of our database using SQLAlchemy, which act as a translator between Python code and the actual database tables. Now let's talk about how users and tasks are connected in our application. In our app, every task is created by one user and the user is either an admin or a member. But that's not all. Tasks can also be shared with another user, like assigning a task to someone else on the team. So each task has two links to the user table, one for the creator and one for the person it's shared with. So it is a one-to-many relationship in both directions. A user can create many tasks and user can be assigned many shared tasks too. This is what makes our app collaborative. Tasks aren't just private to one person. They can be shared, assigned, and managed across the team. The user table store information like the username, password, and the role of the person, whether they are an admin or a member. And the task table stores each task title, description, status, who created it, and who it is shared with. First, we are importing DB objects from our extension.py file. That's our SQLAlchemy database instance. Next, we import user mixin from Flask-Login. This little helper gives our model built-in login features like tracking who's logged in or checking current user. Here we are defining user model. This becomes a database table. We also inherit from user mixin to make this model more compatible with Flask-Login. Every user need a unique ID, right? This line creates the ID column and set it as a primary key. Next up is the username column. It is a string limited to 150 characters and it has to be unique. No duplicate username allowed. Then we have the password. This will store the hash password for the user. Don't worry, we'll never store plain text password. That would be scary, right? Also, if your password is still 123456, this is your sign to change it. This column defines the user role, either admin or member, and by default, every new user is a member unless you say otherwise. Here's where things get a little deeper. We are setting up a relationship with the task model. This means every user can create multiple tasks. The foreign keys equal to task.createdBy part tells SQLAlchemy exactly how the relationship is connected through the created by field in the task model. This second relationship links to task that we shared with this user. So if another user assigned a task to them, it will show up here. The back equal to receiver gives us a shortcut from the task side. So we can just say flask.receiver.username and know who it's shared with. Now we define the task model. This will hold all the tasks in our app. Just like the user model, each task has a unique ID as the primary key. The title of the task limited to 200 characters and we made sure it is required by setting nullable equal to false. Here is the task description. We use text instead of string so we can write longer content if needed. The status column tracks whether a task is pending, in progress, or completed. By default, all new tasks starts as pending. Now this is important. The created by field is a foreign key that links this task to the user who created it. And similarly, shared with links the task to another user that it's been assigned to. So each task is connected to two users, the creator and the receiver. So to summarize, our user model connects to task in two ways: task they create and task shared with them. The task model stores all the task details and uses foreign key to keep everything linked together. This setup gives us the flexibility to manage role, ownership, and sharing, just like a real team task manager should. Alright, let's take a quick walkthrough of how our Flask app works behind the scene, from registration to dashboard and all the way to admin control. First thing first, we are importing the core modules from Flask. Like render underscore template lets you render HTML pages. Redirect and URL underscore for helps you move between routes. And request and flash handle form data and pop-up messages. These are from Flask_Login. They help manage user sessions, basically who's logged in, who's not, and who's allowed to see what. Now we are bringing in password tools so you can store passwords safely, not in plain text. We are importing database instance and two main models, user and task. These hold all the user info and task details. This line set up the Flask app itself. Think of it as the engine that powers everything. This keeps our session secure. You can make it anything. Don't share it in public app. This sets the database. We are using SQLite here. It is lightweight and perfect for small to medium-sized apps. Disable a feature we don't really need. It saves memory and keeps warning away. This line connects SQLAlchemy to our Flask app. Think of it as plugging the database into the main system. This block sets up Flask-Login. It manages user login and redirection. If a user isn't logged in, Flask send them to the login route. This tells Flask how to load a user from the database using user ID. It keeps current underscore user variable up to date behind the scene. Right, let's define our routes now. So this is the root route. By default, when someone lands to the root URL, we send them to the login page. Simple and clean. This is the entry point for a new user. When they submit the form, we hash the password, save their role, and add them to the database. We hash their password for security and save them to the database and redirect them to login page. This route handles users registration, whether you are viewing the form or submitting it. If user submits the form, let's grab the data. Here we are getting the username, encrypt the password and check the selected role, defaulting to member if none is selected. We are checking if the username already exists. If yes, flash an error message and reload the page. If everything looks good, we create the user and save them in the database. Once registered, we redirect them to the login page. Otherwise, we just show the register form. In the login route, we check the credentials. If they are correct, Flask-Login logs them in using the built-in login_user function. Then comes the branching logic. If the user is an admin, they can go to /admin route. Otherwise, they land on /dashboard route. So this route handles users login. We get the submitted username and password and check if the user exists. If the password matches, we log them in and redirect them. Admin goes to admin panel, others goes to dashboard. If the login fails, flash an error message and reload the page. Members can see two types of tasks, tasks they created and tasks shared with them. Here's the member dashboard. This route is protected. Only logged in user can access it. We pull all the tasks the user created and the tasks that were shared with them. And send that data to the dashboard page. If the logged in user is an admin, they can see all the tasks in the system. This route is protected. Members can't access it. This page is just for admin. If a non-admin tries to access this route, we block them. Otherwise, show all tasks to the admin. A member can create a task and assign it to another user using a drop-down list. This route lets a user create a new task. We collect the task info and who it's being shared with. We add it to the database and show a success message. Finally, show the form with a drop-down of other users to share the task with. Only the creator or an admin can edit or delete a task. If not, they are blocked. This route allows a user or an admin to edit a task. Only the creator or an admin can edit, otherwise blocked. If they edit the task, we save it and return to the dashboard. Otherwise, we just show the edit form. This route lets user delete a task, again, if they are the owner or admin. Unauthorized user get blocked. If they are allowed, we delete the task and flash a success message. Calling logout_user clears the session and redirect them to login page. And finally, this part runs the app and create the database if it doesn't exist. And yes, setting debug equals to true helps us catch error while developing. Here is the flowchart of all the routes we just created. This route structure makes the app role aware and secure. Admins see everything, members see what they create and what's shared with them, and Flask handle the login session management behind the scene. Alright, now let's create our HTML pages. So this is our base.html file, the main layout template that every page in our app will extend. We start with the basic HTML structure, setting the character encoding, a page title, and importing Bootstrap 5 for styling. Now this part, our nav bar, it's styled using Bootstrap class to give it a dark theme and spacing. Here is where it gets dynamic. We use Jinja2 logic to change what appears in the navbar depending on the user role. If the logged in user is an admin, we show them a link to the admin panel. Then, for any logged in user, we show the dashboard, add task and logout option. And finally, if no user is logged in, we only show login and register link. Below the navbar in our content container, here we also display flash message like success or error alert. This Jinja code block capture any messages passed from app.py and display them using Bootstrap alert. This is the placeholder for any child template. Like the dashboard, login, or register page, each page that extends base.html will insert its own content right here. So in short, base.html keeps our layout clean, our navigation bar smart, and lets us reuse the structure across every page in our app, all thanks to Jinja2 and Bootstrap. Next, I'm going to extend base.html to all the other HTML templates like login.html, register, and dashboard.html. To do this, I will use this Jinja2 statement at the top of each template. Then I'll start the block section where we place the unique content of that specific page. This content block will automatically replace this code placeholder inside base.html. I hope that makes sense. If you have any questions, feel free to drop them in the comment. I will be happy to help. Now let's go ahead and build out the rest of the HTML template. Alright, we just completed the build phase of this app. Now it is time to test it and see everything in action. This is our login page. By default, when a user accesses the app without logging in, they will be redirected here. Since we don't have any account yet, let me create an admin account and a member account. Then I'll show you how to create a task, share it with other user, and also how to edit and delete tasks. And that's a wrap, folks. We just built a team task manager web app with login, user role, task sharing, and all the essentials you would expect from a real world app. You don't just follow along. You learned how to structure a Flask app like a pro, used SQLite, and manage users and tasks with proper logic. If you ran into any issues or have a cool idea to improve this app, drop it in the comment. I would love to help, or maybe even include it in a future video. If you found this helpful, smash that like button. And if you haven't already, subscribe to EscapeRoomCoding for more hands-on Python and Flask tutorial like this. Thank you for watching. Keep coding. I'll see you in the next video.